This is lesson 5.1. We're going to spend 2 days on it. Not that it's hard, but there is a lot of material in it. So the first day is going to be the properties of exponents, which you guys have seen before, and we've used some of these properties.
And if all else fails, look what's over here.
Yes,
Oh,
Miss
no.
Klingler.
Okay.
So in the room, all the properties are on the posters over there on the side. So the first one says,
Will those be up when we're taking tests?
yes. They're not on a cheat sheet, so yeah. The product of powers, if you are multiplying the same base, so what I mean by base, if you don't remember this, the base is the variable, x and x. So if you're multiplying x to a power times x to a different power,
That'd be X maybe.
you're going to add the exponents. So when you're multiplying the same base, you add the exponents. So this one, example that I have, if you can't see that in the back, I'm sorry, it's small. X squared times x to the third. X squared times x to the third. Make sure you're filling this in on your notes. This would be what? X to what power?
Fifth power.
The fifth. So when you multiply the same base, you add their exponents. The next one, when you're dividing the same base, so now we have a fraction, you do what?
Minus.
Subtract, yep. So if you have x to the sixth over x to the fourth, that's a fraction. I don't know where the line went. X to the sixth over x to the fourth. You would subtract them, which would give you x to the what? Squared. Another way to think about this, which I don't know, it's the same concept. That means you have 6 x's on top and 4 on bottom. If you have the same thing on top and bottom, you can cancel. So 1 here, 1 here, 1 here, 1 here. And then that leaves you 2 on top, so therefore x squared. Okay, so that's another way to think about it. Negative exponents are a little confusing, but if you have a negative exponent in the numerator, in the top of a fraction, that's the numerator, you're going to move it to the denominator and you're going to change it to a positive exponent.
Because you have to make them happy.
Yes, nobody can be negative, except
That's
for
exactly.
we want everyone to be COVID negative.
Right.
So x to the negative a becomes 1 over x to the a. If you have a exponent that's negative in the denominator, you have to move it to the numerator. So if you only move whatever has a negative exponent, and then I always like circle it and draw an arrow to show that I'm moving it or to remind myself to move it. Again, you only move negative exponents. So if I had x to the negative 2 over 1, that is a negative exponent, so I need to move it to the denominator. There's nothing else in the numerator besides the x to the negative 2, so the numerator becomes a 1 and the denominator becomes x squared. So when I move it, I change it to a positive exponent. Ready for the next one? If I have 1 over x squared, 1 over x to the negative 2, again, anything that's negative, basically circle it, draw an arrow to where it needs to go. If it's in the denominator, it's going to move up. So this becomes x to the positive 2. You can put it over 1 if you want, but you don't have to, because it's just a 1. Another example, if I have 3x to the negative 5, what has a negative exponent here? Yeah,
X.
the x does. So only this moves to the denominator. So the 3 stays on top, and then x to the 5th goes to the denominator. So only what has a negative exponent moves. If you had it written like this instead, three x raised to the negative 5. Now that it's in parentheses, all of this has a negative exponent, so all of it needs to move to the denominator as a positive exponent. Nothing is left, or nothing else is up there with that, so we're just going to put it over 1. Now, this simplifies further, and I'm going to come back to that here in a second once we go over that property. The power of a power. When you have an exponent raised to another exponent, or a power raised to another power, when you have two exponents sitting right beside each other, you multiply them. X raised to the a times b. Fill this in on your notes. You should not be on your computer. So an example I have for that, I have x squared in parentheses raised to the 4th power. X squared in parentheses raised to the 4th power. So I have an exponent raised to another exponent, so I'm going to multiply. So this would be x to what power? Just say it, don't.
That's the
8th, yep. Now in parentheses, I have two different things. I have an x and a y. When that happens, you're going to distribute that exponent as an exponent to everything inside the parentheses. So this would become x to the a times y to the a. So an example I have for that is 2y in parentheses raised to the 4th power. 2y in parentheses raised to the 4th power. So again, we need to distribute that exponent to everything inside. I have two things inside. I have a 2, so there'd be 2 to the 4th, and then a y to the 4th. So this middle step you don't have to write. This is kind of just the work. 2 to the 4th, y to the 4th. But you do need to simplify this 2 to the 4th power. If you don't know that math in your head, that's completely fine. Just use your calculator. 2 to the 4th means 2 times itself 4 times. Does anybody know that number? 2 times 2 times 2 times 2. Yeah. 16. Y to the 4th. Okay, now that we did that property, I'm going to go back to this example down here, because now I can do this. I can finish simplifying this problem. I need to distribute that exponent to both terms there. So it'd be 1 over 3 to the 5th is 3 times itself 5 times. Anybody want to guess that number? Or use your calculator if you have it up? You typed in 3 raised to the 5th power. How much? No.
3 times 3 is 9.
5 times.
Oh, I thought you said 3 times.
Maybe I
Sorry.
did. I'm sorry. It times itself 5 times. 2 raised 243. Thank you. And then x to the 5th. So now that we know that property, we can finish that problem. Okay. Let's finish these. And 0 power is equal to 1. Anything to the 0 power. So if I have 3x raised to the 0 power, the only thing that has a 0 exponent is the x to the 0, not the 3. So that x to the 0 becomes a 1. So this is like 3 times 1, which would be 3. If 3x was in parentheses raised to the 0, then all of that is raised to the 0, so then that would be equal to to 1. So you got to watch out for that when you have 0 exponents.
Anytime it's 0 is just 1.
Do what?
Anytime it's 0 is just 1.
Anything to the 0 power is just equal to 1. But over here, the only thing that is 0 power was the x, not the 3. If it's in parentheses, then the whole thing was a 0 power. The last property, it's like the one up above. You basically just distribute that exponent to everything. The only difference is here we have division going on. X over y raised to the a. So this would become x to the a over y to the a. Make sure you fill that in on your notes. So an example I have for that one is x over y, that whole quantity squared. So again, you're going to distribute that exponent to everything, so that would be x squared over y squared. Now, if you have a power of a quotient with a negative exponent, the way that the book says to do this, which is not the way that I would do it, but you still get the same answer. They say to flip it, so become y over x, and then change the exponent to a positive. And then you would distribute the exponent using the property right directly above it. So then distribute the a to both the y and the x, and your final answer is y to the a over x to the a. The way that I do this, and you still get the same answer, I would distribute it first. And then anything with the negative exponent has to move, so that's going to move to the denominator, that will move to the numerator. So you'll see I still get the same answer. So it doesn't matter which way you do that. The example here is x over y raised to the negative 3. X over y raised to the negative 3. Yes?
It is going to be y over y to the third power and over x to the third power.
That is correct. Y to the third over x to the third. If you do it the way that the book says to do it, you would flip it and then distribute the exponent. Okay, so individually, those properties are not too bad to work with, but you're going to have problems that require multiple of the properties in one problem, okay? So your first example, go ahead and fill this in on your notes. The 2a to the negative 2 is already there. Flip your note packet over, or the next page over. The 2a to the negative 2 is already there. Fill in the parentheses. 3a to the third b squared is in one set of parentheses, and then c to the negative 2 is in another set of parentheses. When I see parentheses, the first thing that I always look for is to make sure that there's not an exponent on the outside that I need to distribute. There's not here, but that's the first thing that I always look for because I do that first. There's not here, so then this is multiplication because there's nothing between the parentheses. Okay, so this is understood to be multiplication. So just start with your number first. That's always what you should start with. So my numbers are 2 times 3, which is 6. And then after that, go alphabetical. So start with A in this case. So I have a to the negative 2 and a to the third. When you're multiplying the same base, which we are multiplying, you add their exponents. So negative 2 plus 3 is what? Negative 2 plus 3.
1.
Is a to the first. Now, if there's an exponent of 1, technically you don't have to put the exponent, so you can just leave it a. It's understood to be an exponent of 1. Then do your next variable, which in this case would be b. Again, always go alphabetical. I only see one b squared, so b squared. And then c, it's c to the negative 2. There's nothing else to combine with that. But you need to have positive exponents, so whatever is a negative needs to move. So this right here needs to move to the denominator. Everything else is going to stay in the numerator. And c squared is now in the denominator. Next problem, q squared r to the 4th over q to the 7th r to the 3rd. So start with your first letter, q to the 2nd over q to the 7th. You have 2 on top, 7 on bottom. So if you were to cancel them, how many would you have left and where would they be at? Meaning the top or the bottom. It'd be 5. Where at then if it's a negative? In the bottom, yep.
And then it'd just be R on top, right?
Yep, that it would just be an R on top because you have 4 on top and 3 on bottom, so you'd be able to cancel 3 of them. That'd leave 1 on top. Can I change the screen? Are we good? Okay. In the denominator, put a b squared. There's an exponent outside, so that means I need to distribute that exponent to everything inside. So there's a 2, an a, and a b, and I need to distribute that third power to everything. So negative 2 to the 3rd power means negative 2 times negative 2 times negative 2.
8, negative 8.
Negative 8, yep. A to the 4th to the 3rd. When you have a power raised to a power, you multiply. So it'd be a to the 12th. And in the denominator, I would have b to the, I have squared raised to the 3rd, and so you have a power raised to a power, you multiply, so it'd be to the 6th. Next one, go ahead and fill in on your notes the parentheses, negative 7, x to the 5th, y to the negative 6. Now, I just want to show you really quick, in Delta Math, when you do these problems right here, they will not have that set of parentheses. They won't have that first one in parentheses. They will have the second one, but it means the same thing. Okay, you're still just multiplying. I don't have anything here for an exponent outside of the parentheses, so you just start multiplying. So start with your numbers first. I have 2 times negative 7, which is negative 14. Then start alphabetically. I have x to the negative 3 and x to the 5th. What is that going to give me?
X to the 2nd.
X to the positive 2, because you add your exponents. And let's do the y. Y to the 3rd and y to the negative 6.
Negative 3.
Y to the negative 3. 3 minus 6, 3 plus, yeah, well, 3 minus 6 is negative 3. Negative exponent, we need to move it to the denominator. Now, a common mistake that we see often is that people want to move that negative 14 to the denominator because it's a negative. You only move negative exponents. That negative 14 is just a number. You just leave it there. It's just a regular integer. It's not an exponent. So your answer is negative 14 x squared over y to the 3rd. Any questions about that? Okay, flip your note packet over. We have 3 more problems and then we'll call it good. In the denominator, you should write negative 3 c squared d to the 7th. Okay, Okay, start with your numbers first. 15 divided by negative 3 is what? Negative 5.
Wouldn't that be on the bottom?
Why would it be on the bottom?
Or just a negative?
It's not a negative exponent. It's a negative number. Okay? If we had, I'll show you when it would be on the bottom. If you had the negative 3 on top and the 15 on bottom, that simplifies to negative 1/5. So you'd have negative 1 on top and 5 in the bottom. So you're just simplifying the fraction. C to the 5th over C squared.
C to the third and the C third would go above.
C to the 3rd go above, yep. And what about the D's?
That would be down below D to the fourth.
D to the 4th, yep. So you have 3 on top, 7 on bottom, so 3 cancel, leaving 4 in the bottom. Next one, A over 4 raised to the negative 3. Doing this the way that the book did it in the example, they say to flip it and change it to a positive exponent and then distribute the exponent. What is 4 to the 3rd power? That's 4 times 4 times 4. Thank you. Okay, so that's your answer. 64 over a to the 3rd. Last problem. In parentheses, you have negative 2x to the 3rd y squared raised to the 5th power. And just distribute your exponent to all 3 items. So negative 2 to the 5th power means negative 2 times itself 5 times. Negative 2 raised to the 5th power. Negative 32. Okay, now we have x to the 3rd raised to the 5th. When you have a power raised to a power, you multiply.
15.
Yep, 15.
And then 10.
And then y squared raised to the 5th. Again, you multiply, so y to the 10th. Oops, that looks weird. There we go. Okay, so again, today we're just going to deal with exponents, so that stops that part. We'll do the rest of the lesson tomorrow.